falling drops of rain, drawing up flocks of goldfish on canvas made of puddles. We made the body mesh and animation in the last video. In this episode, we'll make the attachments. More specifically, dorsal fin, pelvic fin, pectoral fins, and eyes. We'll omit the anal fin since it's not going to be visible anyways. In order to make attachment parts, we'll need to use information from these two objects. Join these two outputs together using join geometry. Select the join geometry and Ctrl G to group it. Just select the join geometry and Ctrl X to delete. Open up the side panel with N, then rename the mesh input to body mesh, curve input to curve. Reorder if inputs are switched. This node group will serve as template since all attachments have same ins and outs. Duplicate with connections using Ctrl-Shift-D. Click on this number to make it into a single user. Then, rename to Make Dorsal Fin. It is a fin on the back. Connect this result to group output. Let's start making the fin inside the node group. Making dorsal fin is pretty simple. All we do is raycast this curve upwards, then turn it into flat mesh at hip position. First, connect the curve to output, then add set position. From position socket, connect the raycast hip position. Then, connect the body mesh to target geometry. Turning the ray direction to positive Z will cause curve to shift to the top of body mesh. Let's trim it down using trim curve. Change trim mode to length and enter 0.2 and 0.6 to leave the necessary portion. Then, resample with fixed 10 count. Add a transform geometry and shift it down in Z direction by 0.01 meter. This is to leave a bit of extra mesh in case we decide to subsurf later. Then add a set curve radius and connect radius up to flow curve. Connect the spline parameter factor to float curve value. After set curve radius, add a curve to mesh and use curve line for its profile. Change the endpoint Y to -0.1 and Z to 0. Then resample it to fixed count of 5. I want to display the body mesh while adjusting the fin, so add a join geometry at the end and connect body mesh from group input. Adjust the float curve and shape the fin to your likings. Dorsal fin is complete. I'll display the full node group, so check your settings if things aren't right. Now let's move to the eyes. Rename the empty node group we made in the beginning to Make Eye Mesh. Connect it up to group output. We'll use icosphere for base mesh. Set the radius to 0.03 and subdiv to 2. Then connect to output. Next, add a transform geometry, then squash it down by setting Z scale to 0.5. Duplicate the transform geometry and branch. Then enter 0.5 to all scale direction and join it to the top with join geometry. Enter 0.01 to Z translation to have its iris appear. Using geometry to instance, combine these two meshes to single instance. The way we'll attach this eye mesh is, first, we'll decide at what length eyes should be at on the curve. Then, with normal turned at certain angle, raycast towards the body to get its attachment position. Okay, add a set position after geometry to instance. Connect position to raycast hit position. Then, connect body mesh to target geometry. We'll add a body mesh reference so we can see its relative position. We'll need a source position, so pull out a sample curve from curve input. Change the mode to length and enable all curves. Then, enter 0.1 meter in length and connect position to source position. Eye is now shifted towards body, but is attached on its chin. We want to specify angle and not vector for ray direction, so from this normal, connect it up to vector socket of vector rotate. Then, use tangent for its axes, and plug the result into ray direction. Eye mesh is now attached to specified angle. Eye is now facing upwards, so let's align it to the body mesh surface. Add a rotate instance after set position. From raycast, hit normal. Pull out a align rotation to vector and connect to vector. Plugging the result into rotation of rotate instance will cause eye to align to surface. We'll be using this length, so let's promote it to a single value. Change its name to attach length. Same with angle. Call it attach angle. Excluding the value nodes we just made, select these nodes and Ctrl-G to group them. I'll just clean up the input connections. Open up the side panel with N and rename target geometry to body mesh. Length to attach length, angle to attach angle. Call this node group attached to body. Reorganizing. If my memory serves me right, fishes do have two eyes, so let's make another. Select the group input and the node group, then Ctrl-Shift-D to duplicate. Then bring it down. Connect the result to join geometry. To mirror the eye position, add a mask subtract and enter pi on the top value. Connect the attached angle to the bottom and reconnect. Now eyes are placed on both sides of the body mesh and can be adjusted by changing attach angle. I think the value of -0.1 is okay. Eyes are complete. Here's the overview of the node group. Attached to body will be updated later, but here is the current status. Next, pelvic fin. We'll start off by duplicating the Make Eye Mesh node group with Ctrl-Shift-D. Turn it into a single user. Then, rename it to Make Pelvic Fin and connect to output. We don't want the eye mesh, so delete this portion. Move to the left for more space and add a curved line. Instead of connecting to output, I'll just use a viewer to work on this fin mesh. Add a resample curve and fix it to 5 count. Next, set curve radius and connect flow curve to radius. then spline parameter factor to value. Add a curve to mesh, and use curve line for its profile. Let's not forget to resample down to 5 counts. We can't see anything at the moment, but setting curve line to be between negative 0.5 and 0.5x will result in this shape. Let's now edit the float curve so it looks more like a fin. Then, add a transform geometry after curve to mesh, and reduce its scale to 0.2 in all directions. Connect the result to geometry to instance, and delete the viewer to see its output. Now we got some fin 4-eye creature, but it can be resolved by setting attach length to 0.6 and attach angle to 1. The fins are spread too wide, so let's modify attach to body to adjust its angles. First, make some space after raycast like so. From hit normal, pull out an axis angle to rotation. Then, connect the result to rotation socket of align rotation to vector. Connect up a group input to angle socket to make it into an argument. Next, duplicate rotate instance to the right. Disable local space. Then, connect hit position to pivot point. Connect a combine XYZ to rotation, and make Z value into argument by connecting a group input. Open up the side panel. Rename angle to normal angle. And Z to Z angle. Attach to body node group is now complete. Tab out and let's start setting the parameters. If we change the normal angle, we see the fins rotate perpendicular to the body mesh. Connect up a value node and rename it to normal angle. For the bottom fin, duplicate the subtract. Reconnect it up like the attach angle. For the value, negative 1.5 looks good. Changing Z angle parameter causes local Z axis rotation. Let's pull out a value node, rename it to Z angle, and enter 1 for its setting. For the bottom, multiply the value with negative 1, then reconnect. Pelvic fin is now complete. It moves like this when we run the animation. Okay, here's the overview. Tab out so we can start making the pectoral fin. Ctrl-Shift-D the make pelvic fin we just made. Turn it into single user and rename to make pectoral fin. Then connect to output. We can just use a pelvic fin mesh we made, so let's adjust its position. Set attach length to 0.2 and attach angle to 0.8. Placement looks great, but unlike pelvic fins, we need to add animation to this one. Let me add a reroute to reorganize. So let's confirm the movement range by changing this Z angle value. By its looks, value of 0 to 1.5 seems good. Let's now add a map range and set its 2min and 2max value to 0 and 1.5. Delete the value node and replace it with sign. Then, connect up with scene time. Change the from min value to -1 to match sign range. Let's confirm its movement. Fins are moving, but not in sync with the body movements, so insert a mask multiply after scene time. Connect it to group input to make it into an argument. Tab out of the node group. Then, connect the movement speed we made for set body movement to group input. Duplicate the group input and connect it to the new input we made for make pectoral fin. Let's reconfirm the animation. Now the fins and body motion is in sync. Let's not forget to properly name the input. Call it movement speed to match the top input name. Pectoral fin is now complete, so let me share the full view. All attachments are finished, so we'll connect them all up to make them into single object. But before we do that, we'll need to delete the reference body mesh we added in each node group. The actual body mesh will be outputted from the make body mesh, so they are no longer necessary. Let's connect the join geometry from make body mesh. Then connect all the attachments to join geometry. When we run the animation, we can see it all in action. You can make final adjustments as you please. I feel the pelvic fin is too large, so I'm going to shrink it down a bit. For rendering preparation, let's add a set shade smooth and also subdivision surface. Subdiv will cause an increase in geometry count, so make sure to balance it with your PC performance. Personally, I think it's unnecessary since we aren't really thinking about close-ups. Let's add some arguments for external control. Make movement offset into an argument. And also level of subdiv, so we can change it based on final render quality. Geometry input is not needed, so we'll just delete it. Lastly, I'll just name the node group to Goldfish. After a little reorganizing, let's go over the node tree. This is the top. We made the attachment on the right. Inside the make iMesh. Attached to body is reused, so we'll just show it here once. Next, make dorsal fin. Make pelvic fin. Lastly, make pectoral fin. We are done with goldfish mesh and animation. In the next episode, we'll be making the goldfish material. Hope to see you in the next one.